Okay, so this part is the practice problems that I gave you, and I'm going to show you my thought process while I'm grading these. So very first thing is I look at them and I look to see what things are given to me. Well, I'm given a conditional statement and a proposition, so that's either law of detachment or modus tollens are my options. So I'm looking at this, if S then not Q, oh, I have Q here. That is negated conclusion, so therefore I should have a negated hypothesis. That is strictly modus tollens. So kind of cool. Then I look at the next one. I'm like, okay, I have not P then Q. Oh, look, I repeat the conclusion. Wait, I can't repeat the conclusion. That's not law of detachment. In modus tollens, I would need a negation symbol, and then that would make that a P. I don't have that. That's not what I have written down, so I have a no valid conclusion on that one. On the next one, I want you to remember this whole thing is your hypothesis. And so I have a conditional statement, and this actually ends up being another proposition because it's the conditional statement's hypothesis repeated. So I'm like, wait, I repeated the hypothesis. Notice I have this straight up and down here. Therefore, I can get the conclusion, and that's going to be law of detachment. All right, let's look at the next one. I'm given a single proposition and a conditional statement. Now when I look at this, I go, okay, here's my conditional. What did I work with? Oh, I worked with the hypothesis and I negated the hypothesis. I have no law that tells me I can negate the hypothesis to get a negative conclusion. That is a non-valid conclusion. It's not valid. It's not LD or MT. Now let's look at the next one. I'm given two conditional statements. Okay, if I have two conditional statements, I'm going to look for LS. And sure enough, I have it. Why? Because I have a conclusion and a hypothesis that's the same. When you do that, you get if P, then Y. And that is going to be, in this case, LS. Then I look at the next one. I have if not M, then T. If R, then not M. I still have two conditional statements. Notice hypothesis and conclusion that are being repeated. Remember, they simplify out, and I get if R, then T. That's law of syllogisms. So kind of cool. Now, I look at the next one. I'm like, hey, look, another LS. I have, oh, wait, M then R, if M then P. I have this problem. I do have a repetitive proposition, but they're in the same spot. Therefore, it's not following the rule of LS. These are not going to help me at all. I cannot say, oh, I get a new conditional statement. There's nothing that can simplify out. So that's LS. Now the next one is just a rule that doesn't work. And I want you to remember, do not distribute negation symbols, okay? And when people do that, they get it wrong. I actually got it wrong on the validity problems that people had earlier on the previous page of your quiz. Do not do that. This is a no valid conclusion. That is not a valid logical argument. All right, look at number 9. I'm given a single conditional statement. Oh, look, I've done with the switching and negation. Oh, wait, that's law of contrapositive. Now I'm going to look at the next one. It doesn't look like it's valid on first glance. I get if P then Q, if not R, then not Q. Therefore, if P then R. But I want to remind you, if in doubt, try law of contrapositive. I'm going to change that using LC. Look what I get. I get here, actually I might put it up above it. Let's go up above it. I'm going to get if Q, then R. Oh, look, now I have conditional statements. Hypothesis, conclusion being shared. Oh, look, therefore if P, then R. So basically, I used LS, but first I had to apply LC. So my answer is LC, LS. Now look at the next one. Can I combine these two? You bet I can. I can totally go if D then F, F then E. I can use LS. What do I get when I do that? I get a therefore if D, then E. Oh, look, now I have a conditional statement and I have a hypothesis being repeated, therefore E. So I used LS and LD. Now, a person could also use, with this one, law of detachment twice. Now I'm going to show you the next one. Can I combine these two? Yes, I can by modus tollens. I get a therefore what? Not N. Oh, look, now I have a not N and I have therefore not N, then D. Oh, look, that's law of detachment. So those two combined used LD. So this one was modus tollens and law of detachment. All right, guys, I hope this helps you out a little bit and works well for you.